want to do is we're going to do division of polynomials. So first we're going to start here with number 1. So I look at my 6x and I say, okay, how many times does 6x go into 12x squared? I know that 6x times 2 is 12, and I know that x times x is x squared. So if I multiply the 2x times the 6x, since this is an expression, I need to make sure that I multiply the 2x times the negative 3 as well. So I go 2x times 6x, and I'm going to get 12x squared, and then 2x times the negative 3, and I'm going to get negative 6x. So just like normal division, what I would do is I would subtract those two. 12x squared minus 12x squared is going to cancel out, and then I have 18x minus negative 6, which is the same thing as 18 plus 6. So I'm going to get 24x. All right, I'm going to bring down the negative 17, and I'm going to say the same thing to myself again. How many times is 6x go into 24x? Well, I know 6 times 4, a positive 4, is 24. So 6x times 4 is 24x. And I have to multiply this by the negative 3 as well. So 4 times negative 3 is negative 12. So just like before, I'm going to subtract these two. 24 minus 24, this is going to cancel out. Negative 17 minus negative 12 is the same thing as negative 17 plus 12. And I'm going to get myself a negative 5. Since there's nothing else here to bring down as my remainder, since there's nothing else here to bring down, 5 is going to be my remainder. So I'm going to write my answer out as 2x plus 4 plus negative 5 over 6x minus 3. And that's the answer for number 1. So the next one, we're going to be using synthetic division. My problem is set out. I'm going to use the opposite of negative 5 right here. So I'm going to put my 5 in a little box. And then I'm going to take the coefficient of each term in my polynomial. So I'm going to have 3. I'm going to put a 0 here to take to be as a placeholder for x squared. Then I have negative 70, and then I have 2. So when we are using synthetic division, the first thing that we want to make sure that we do is we bring down our first term. Then we're going to multiply this term by our number in the box. So 3 times 5 is 15. And then now in the second column, we're going to add these two terms. So we go 0 plus 15 is 15. Next, what we're going to do is we are going to multiply 15 times 5. And that gets us 75. So I'm going to put 75 right here. Negative 70 plus 75 is going to get us 5. 5 times 5 is 25. And 2 plus 25 is 27. So now that we are all done here, we're going to say, okay, well, if I'm dividing x cubed by x, then I'm getting rid of an x. So my new highest exponent is going to be x squared. So I take this term right here, and I'm going to write 3x squared plus 15x plus 5. And if you get a number in this last column, that means you have a remainder. So I'm going to add 27 over x minus 5. And that is your answer for number 2. All right, so for number 3, we're going to be finding P of A using the remainder theorem. So when we're asked to use or to find P of A for the remainder theorem, what we're really just looking for is that remainder. So I'm going to start first by putting the value for A in the magical box. So we're going to have a little 3 in the box here, and I'm going to list all my coefficients like I did for number 2. So I have 5, -12, 2, and 1. Since I have my 3, 2, 1 situation here, that means I don't have to put any placeholders because all of my exponents are there. All right, next, we're going to set this up. Always bring your first term down. So 3 times 5 is 15. -12 plus 15 is 3. 3 times 3 is 9. 9 plus 2 is 11. 3 times 11 is 33. And 1 plus 33 is 34. So when we're trying to find that P of A, we want to figure out what the remainder is. Our remainder here is 34. So we write our answer as when P is 3, our remainder is 34. Number 4 asks, how do you know if the binomial is the factor of the polynomial? You know it's it's a factor if your remainder is 0. All right, so for number 5, what you're going to do is you're going to start by plugging this into your calculator, and I'm going to show you how.